Hi there. For this video, we'll be talking about factoring four terms. Specifically, we'll use the factoring by grouping method. So let's have this one as an example. If we have ax minus ay plus bx minus by, what we'll first do is we'll try to group these terms out here in such a way that we can factor out a certain term out here. Observe that the first term has a common factor of a with the second term. The third term has a common factor of b together with the last term. So, pairing this up, we'll have ax minus ay plus bx minus by. Since we know that this two has a common factor, we can factor this one out. This one as well. So we will obtain a times x minus y plus b times x minus y. Now from here, observe that the expression that is left inside in here are the same. In fact, we can actually factor that one out. Since if we have, say we let z equals x minus y, then we'll have az plus bz, which we know that this will be z times a plus b. So applying this same idea, factoring out x minus y, we will have x minus y times the expression left inside is a plus b. And so that is the factored form of this polynomial. Let's have another example. If we have 2ax minus 4az minus 12bz plus 6bx. Now for this one, it's kinda hard to find which terms should we pair, since we both have a here, we also have both b here, but we also have both x here and both z here. Now to determine how we could pair this one up, a great way to check is to check the ratio of the coefficients. So for instance, if we are aiming to pair this two and this two, let's check the ratio of its coefficients. 2 over 4 is equal to 1/2. On the other hand, we have, it should be -4. And this one, we have -12 over 6, which is -2. So, it doesn't match. But observe that if we switch the places of these two, then this ratio out here would also be reversed. So it will become 6 over -12, which is -1/2. So it now matches with this one. So that is the first thing that we would do. We would switch the position of this one up. So this will be 2ax minus 4az plus 6bx minus 12bz. Now from here, we can now pair this 2 and this 2. So this will become parenthesis 2ax minus 4az plus parenthesis 6bx minus 12bz. Factoring out the common term, in this case, we have 2a, and this one, we can write this one as 2 times 2a. For this one, the common term is 6b, and this one, we can write this one as 2 times 6b. So the expression will become, factor out 2a, expression left inside is x minus 2z, since there's a 2 left here. On the other hand, we'll have factor out 6b times expression left inside is x minus 2z, since we have a 2 left out here. So let's clear out some space. Now, similar to what we did a while ago, since the expression left inside is the same, we can factor that one out. So we'll have here x minus 2z, and what's left inside is 2a plus 6b. Observe here that we can still factor out a 2 here, since 6 can be written as 2 times 3. So we'll have factor out the 2 times x minus 2z times a plus 3b, since there is a 3 left out here. And so this is the final answer for this problem. Let's have this third example. If we have x squared minus y squared plus 4y minus 4. Now for this one, observe that we can't use the trick that we did a while ago, since only this 2 has a common factor, or maybe this one. But x doesn't really have any common factor in here. So we can't use the method of pairing 2 of the terms. So what can we do instead? Let's try to group 3 terms this time. Observe that we can write this one as x squared minus, let's try to group these 3 terms. So if we'll have a minus sign out here, y squared will be positive, since if we distribute this one, it should become negative out here. On the other hand, positive 4y should be negative 4y, since if we distribute the negative sign, negative times negative becomes positive. And the third term will be, or negative 4, this should become positive 4, since negative times positive out here would result to negative. So this is the new form of our polynomial. Now observe here that this one is actually a perfect square trinomial. So you can verify that through perfect square trinomial, this trinomial is equal to y minus 2 squared. So this one out here becomes x squared minus y minus 2 squared. And what can you observe? We have a square out here and a square out here. So we can apply the difference of two squares. So applying the difference of two squares, this becomes x plus y minus 2 times x minus y minus 2. Simplifying, this becomes, the first term is x plus y minus 2. The second term becomes, distribute the negative sign out here. Second term becomes x minus y plus 2. So this is the factored form of this polynomial. Let's have one last example. Let's have x squared plus 6xy plus 9y squared minus z squared. Observe here that z squared doesn't have any term in this polynomial that it can pair b with. So we can't use the first method that we had a while ago. So we'll try to group three. We would try to group three terms this time. Specifically, this 3. So this can be written as x squared plus 6xy plus 9y squared minus z squared. And observe again that this 3 actually forms a perfect square trinomial. You can verify that applying the perfect square trinomial, this one is equal to x plus 3y squared. So this becomes x plus 3y squared minus z squared. And again, since we have two squares and a subtraction out here, we can use the difference of two squares. So applying the difference of two squares, this becomes x plus 3y plus z times x plus 3y minus z. Simplifying, we obtain x plus 3y plus z and x plus 3y minus z. So this is the factored form of this polynomial. Now, before I end this video, here are two exercises that you can work. First, we have 2c cubed plus 3c squared minus 50c minus 75. The second would be 4 minus 4w squared minus v squared plus 4vw. So basically, in this first example, you'll apply the first method that we did, wherein we try to pair this up, these terms up. For this second one, we'll try to apply the last method that we use, wherein we'll try to pair, or rather we'll try to group three terms this time. So feel free to comment your solutions or your answers to this one to verify if you got the correct answer. And so that's it for this video. And yeah, hope you enjoyed it. Thanks. And that's it. That's all for this video.